Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Entropic Snowflake by Railman, and here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once in every row, column, and box. Colored lines are entropic lines, so that means all of these lines are entropic lines, where every 3 consecutive cells along an entropic line must contain a low digit, which is 1, 2, or 3, a middle digit, which is 4, 5, or 6, and a high digit, which is 7, 8, and 9. So every 3 cells along an entropic line has to have 1 low digit, 1 middle digit, and 1 high digit. And different colors just show different lines. So that allows us to distinguish that this is a line and this is a line, really. So as an example, we could have something like, say, 8, 7, and that's not right. 8, 3, and 4. And this would be valid because on this entropic line, we have a low digit, 3, a middle digit, 4, and a high digit, 8. Or along these 3 unique digit, or this 3 cell span on this entropic line. We have those 3, one of each of the digits, a low, middle, high digit. Okay. Digits separated by a white dot are consecutive, and digits separated by a black dot are in a 1:2 ratio, and not all dots are given. So as an example, if this were 3, this would have to be 4 or 2 here. And if this were 2 here, this would have to be 1 or 4 to maintain the 1:2 ratio. And these digits have to be consecutive because there's a white dot between them. This has to maintain the 1:2 ratio between them because there's a black dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so what I like doing for any set of periodic lines which alternate sets, sorry, is that any line that alternates sets on that line, is I like to just choose a random color and just color it, right? And the thing is, for an entropic line, every third cell on the line will be of the same set. And the reason why you know that is, say you have 3 digits here. These are all going to be different sets because every 3 consecutive digits on that entropic line has to have one of each set. So these are one of each set. If we go for these 3 digits, we're losing this set here. So this set must be exactly the same as this set and this set, right? So because these 3 form one of each set here, this forms one of each set here, and this must form one of each set, and these 2 digits are the same, so therefore their sets are the same, and we lose that set, so therefore we must gain that set to make sure that this is kosher. So we're gonna make this pink. This will make these have to be, so we know 3 away has to be pink and pink. So we have pink here and pink here, which means the rest of the box cannot contain a pink set. Sorry, the rest of the row cannot contain a pink one because we have 3 pinks. And we'll make this orange, we'll make this yellow. We don't know if they are the same set here. They could be, but we don't know. One thing we know, though, is these here and here and here have to be consecutive, yet be in different sets. The only possible combination for those are 3, 4, 6, and 7. right? Because no other consecutive digits are from different sets. So this has to be 3, 4, 6, 7. That forms a 3, 4, 6, 7 triplet in the box, which means this cannot be 3, 4, 6, 7. So it has to be 1, 2, 5, 8, 9. Did I say triplet? Quadruplet in the box. 3, 4, 6, 7 quadruplet in the box. And this must be 1, 2, 5, 8, 9. But these digits cannot be pink. So therefore, where is 5? That means we cannot have pink in any of these. That means this digit is going to be the same digit, or the digit that is by itself. And the only digit that's by itself is 5. So this must be the middle set here. So this is 5, which eliminates 5 in the rest of the box. This then must be a 4-6 pair. This is 4 and 6. This is 4 and 6. And these digits must be consecutive with 4 and 6, and they cannot be 5. So this must be 3 or 7. And if this is 4 and 3, this would force this to be 6, which would be in a 1 to 2 ratio only with 3, and we'd have a duplicate 3 in this row, which is not allowed. So this cannot be 4 and 3, therefore this must be 6 and 7 here, which makes this 4 and 2 or 8 here. Well, since we already have a 7 here, that's a high. We are guaranteed in this set 2 highs here, which means this cannot be high. It's low, which makes this a 2. So there's no 2 here, which means one of these is a 2. Since one of these is a 2, the 1 cannot be here. Also, these digits are consecutive. So this can't be 1 or 9. It's 2 or 8 consecutive with 3 or 7 here. So these are the same set no matter what. So these are both yellow, which means this has to be 3 or 7 to 4 or 6 here. So this is green. That means only one of these can be yellow. We don't know if it's the orange or not. We're going to make an executive decision and say that the orange is going to be the other color. So therefore, this is orange here, 1 orange and 1 yellow here, and this must be orange. That means remaining digits in row 5. 2 is one of these. 1 cannot be here because if that's 1, that would force this to be 2, but there have to be different sets because of the 3 consecutive digits on an entropic line have to be different, one of each set. So this cannot be 1 here. We are guaranteed 1 here. We're guaranteed 2 here. This has to be middle here at the end, and this is middle. So since this is orange, this must be yellow. This is yellow, this must be orange, because every third digit is the same. So this is guaranteed to be 3, 8, and 9 in the rest of row 5. This is 4, 6 as a pair. This is 4, 6 as a pair. 4 and 6 can be in a 1-2 ratio with 2, 3, or 8. So again, if this is 4, that would force this to be 3. This would then have to be 6, which is only in a 1-to-2 ratio with 3, and we'd have a duplicate 3 in the column. So this cannot be 4 and 3. This must be 6 with 7 there. That makes this 8. So the yellows have to be high. And the oranges are low. So this has to be a 2 here. This is 1 or 3. This is 4 in a 1-to-2 ratio with 2 or 8. We're not sure which. This is 1 or 3 here. This 7 eliminates 7 in the rest. This can't be 6 and 7. Therefore, this has to be a 3, 4 pair. This can't be 7. This can't be 7. So these can't be 6s here. 4 here eliminates 4 here. So that's 6. This must be 7 or 9. This digit is not high or medium, so this is low. And it cannot be 3 or 4 because of the 3, 4 pair in the row. Since this is low, and this 4 eliminates 4 here. So this is 3, which makes that 4. So this must be low here. This is medium, and this is high. This 3 eliminates 3 as a possibility here, so this can't be 3. It's 8 or 9, which is guaranteed to be high. This can't be high then because we need one of each set here. Therefore, that makes this high, and this is a low. So this is low. It's 3. This has to be 8 or 9. This is 1. This is 8 or 9. And this 8 eliminates 8 here, so that's 9. Makes that 8. This cannot be 3 or 4 here because of the 4 in the column, so this is 6 and 7. So this is 6, which is medium. This is high, and this is low, so that's a 1. This cannot be 6 and 7, so it's a 3-4 pair, but this can't be 3 because of 3 in the box, so this is 4. That's 3. That leaves this as low, this as middle, and this has to be a high. 7 eliminates 7 here, so that's 9, which makes this 8. 8 eliminates 8 in the rest of the column, so this is 2, which means this is a low. This is 7 as a high, so this must be high over here. And this is a blue. This cannot be... So this is medium, which makes that medium there. This is medium, which makes that medium there. This is high. We don't know which. This can't be low, so this is medium or high, but this can't be high because we have 3 highs in that row already, so this is medium, which forces this to be high. So this is 7, 8, or 9, which is consecutive with 6, 7, 8, 9, but 6 in the row eliminates that as a possibility. So this is a high. And the only high, which is in a 1 to 2 ratio with another digit, is 8. So this is 8. This is 9. That must be 4. So this cannot be 8 here. It's 7 or 9. This is medium here. We have a high digit remaining in column 5 and a low digit. But high cannot be here because we have 3 highs already in the box. So this must be low, which makes this a high digit. So this is 1 or 3. That's consecutive with 2 or 4 here, but this cannot be 2 because of 2 in the column. So this has to be 4 here, which is only consecutive with 3 out of 1 or 3. So that's 3. This is 1. This is 7 left as a high digit. This is low 4. Okay. These have to be medium or low here. And so 1, 2, 3, 4, 5, 6. This is 1 or 2. No 3 or 4 here. No 6 or 1 here. This is 2 or 5. No 2, 4, or 6 here because of 2, 4 in the row and 6 in the column. So we're guaranteed one of these is a 5. Because we have to have one medium here. So then one of these is 5 here. This 1, 3, 5 is consecutive with 2, 4, or 6. And this cannot be 6 because of 6 in the column. So this is 2 or 4. These digits cannot be medium, so we have 1, 2, 3, 7, 8, 9. This can't be 1, 3, or 8 because of 1, 3, 8 in the column. This can't be 2 because of 2 in the row. Same with these. These are 1, 2, 3, 7, 8, 9. This cannot be high because of the 3 highs in the column, or sorry, in the row. So therefore, this must be low, which makes this a high digit for one of each set on this set of 3 digits. We have 3 lows in column 7, so this cannot be low here. That's high, which forces this to be low here. So this is not 7, 8, 9. This is not 2. We have 7, 9 here. 1 and 3, which is consecutive with 2 and 4, but this can't be 4 here because of 4 in the column, so this must be low and is 2. That eliminates 2 from being here, so that's 5, which means this cannot be 5 here, and it has to be a low. So this is low, this is medium, and 5, and this 4 and 5 eliminate 4 and 5 here, so that's 6. This can't be 1 or 3 because of 1 and 3 in the column, so that's 2. This is a high digit, which is 7 or 9, which can be consecutive with 6 or 8. Let's see. What else can we do? Where is... So... This digit cannot be all highs because we have 3 highs in the column. This digit cannot be low because we have 3 lows in the row, so this has to be medium here. And it cannot be 4, 6, so this is 5. That leaves, excuse me, the remaining digits in row 4 as 3 high digits. This has to be a 7, 9 pair because of the 8 in the box, so this has to be 8 here. That leaves the remaining digits in box 4 as 1, 2, and 9. But this can't be 9 because of 9 in the column, so this is low, which makes this 9 and a high. So that means 9 eliminates 9 here, so that's 7, which makes this 9. 9's consecutive only with 8, so that's 8. This is 7 then, which is 9. This is a high digit. We don't have highs remaining then in column 8. Where is 9 available in box 1? Can't be here or here because of 9's in the column. Can't be here because of 9 in the row, so 9 has to be here. Where's 5 in box 1? Cannot be here or here because of 5 in the rows, or 5 in the columns. So this has to be a low, and this must be a low. And one of these is going to be a 5. We don't know which. We have 3 lows and 3 middles in column 3, which eliminates low and middle in the rest of the columns, so these are all high. So this must be 7, 8, and 9, and this can't be 7 or 9, so that's 8, which makes that 7. We have 3 lows already in row 8. That means this can't be low here. We need 3 lows in column 1, so therefore this must be low, and this must be medium. And as a medium, it's a 6. We have 3 lows already in row 8. And the only remaining digits in this cell can only be low or medium because we have 3 highs in that column. So this has to be medium here. This 1, 2 forces this not to be 1 or 2, it's 3. Which means this can't be 3, it's 1, which makes that 2. So these are both low. 1 eliminates 1 here, so that's 3. This has to be 4 as the last remaining medium digit. We have the 3, 5 pair here. This can't be 3 because of 3 in the row. So this must be medium and 5. And this must be low and 3. Okay. Remaining digit in row 7 has to be a high digit. We have 1 and 5 remaining in row 3. This is 1 or 2. We have 1 or 2 here. We have to have a 7 somewhere in row 1, and it cannot be here because of 7 in the box, and this is medium, so this must be 7 here. So this is 7 and is the high. We have 3 mediums now in row 1, so this has to be now a low. And this can't be 1 or 3, so it's 2 because of 1 in the column, 3 in the row. 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here, so it's 2 and 1. We have 1 and 5 remaining in box 2. This can't be 1 because of 1 in the column, so this is medium and is 5. This is low and is 1. So we have 1 here, this is 5. That leaves a 5 remaining in column 4. And we have 8, 9, and 3 remaining in column 6, apologies. And 3 cannot be either of these digits, so this must be 3 here and is low, which makes this red. So this has to be 3. We have 8 3s. We know where the last 3 has to be. It has to be there. So that's 3, which leaves this not as low, it's medium, and that's a 4. This has to be a 6. This can't be 5 or 6, so that's 4. 7 eliminates 7 here, so that's 9. This can't be 9 here, so this must be 8, which makes that 9. That leaves this as a 7 there. Remaining digits of row 6 are 5 and 6. This can't be 6 because of 6 in the column. So this must be 5, and that's 6. 5 eliminates 5 here, so it's 1 and 5. So therefore, this is low, this is medium. We have a low remaining in column 8. We have 2 mediums in column 7 and 1 high in column 9. And this must be a 1 here. This has to be 8, that's 5, and that's 6. And that's how you solve it. Yeah, fairly straightforward. The break-in was pretty easy. Yep, just overall fairly simple puzzle here, with certain restrictions, obviously, on especially the white Kropke dots here, right? That was, I think, the key. And then also these 6, 7, these 4, 6 pairs with 3 and 7 being consecutive, with a 2 or 8 being on the other side. Those were the key break-ins, I guess. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.